Hello there, my name is Anand Rajamani, and welcome to the fourth video in the Program Your Robot series. In this video, I'll be covering the code needed to implement PID control on the RoboRIO. If you haven't seen it yet, check out video 3 for some instructions on implementing PID control using Phoenix Tuner and the Talon SRX. So I've got my basic robot project here, robot.java that hasn't changed, drive percent that's going to drive the robot when I push joysticks, test motors that's going to do all my setup for motor controllers, and my initiates my default command as drive with percent. We've got OI, that's just going to map my joysticks to commands and that sort of thing. And rope map, which is going to have a lot of constants in it. So how do we go about implementing PID control in this? Well, fortunately, if you've already gone ahead and tuned everything with Phoenix Tuner, it's a pretty straightforward process. The FAQ has some example code on how to set up PID, but it's overall very straightforward. So first thing I'm going to do is I'm going to go ahead and define my constants in rope map. So in my test motors subclass thing, I'm going to go ahead and let's see. We need a few things. First of all, we need to define as our sensor direction. So make a public static final boolean sensor direction. Let's see, false. So this is going to be when I set my sensor phase to make sure that positive output corresponds to positive movement of the actuator. You need to make sure that's a thing. Then I'm going to want to define my KP and stuff. So again, I'm just going to copy this real quick. Public static final double KP position, in case I want to do a velocity PID as well, equals, what did I define my constants as? Here we go. 1.5 final double, we want KI integral term. Again, for position is going to be 0.0003, if that's correct. Yeah. KD of 90 and a ramp of 0.2. Double KD position equals 90. And was that a final double closed loop ramp equals 0.2. Okay. And so these are the things that we did in video 3. We found those constants. If you haven't checked it out yet, go do that. And that should, and last thing, we need to make an integral zone. So final int integral zone equals 100, and that's just going to limit, when I can use my integral term, so I don't get integral wind up. Okay, so that's a constant setup there, pretty straightforward. All right, and next I'm going to go into test motors and do all of my setup code. So in test motors, we still have all this stuff we had before, config factory default. We set a neutral mode of brake. That's not really going to do much in closed loop mode, because the way closed loop works, you're never really going to be in brake mode. I invert the master to whatever the setting is for invert master, and invert slave. That's defined in false for both, actually. And I've got the follower set up. Okay. So now, in controller init, we need to add a few setup lines. So first what I'm going to do is I'm going to say master talon dot config selected feedback sensor. Here we go. That's the one. Feedback device, we're going to want to do a feedback device dot ctre magnencoder relative. That's what we're using on the verse planetary encoders. For PID index, that's going to be index 0. That's going to be inner loop or outer loop. Keep in mind, not PID slot, different things. And for timeout, I'm just going to do my regular robot map dot timeout. Blech. There it is. Okay. Robot dot timeout. Got that. So we've said to the Talon, this is the sensor that we're using. Fine. You can also configure remote sensors or that thing. We also need to do the sensor phase. So set sensor phase. Let's do a phase of robot map dot test motors dot sensor direction. There it is. And we set that up in the last one. We didn't set up through Phoenix Tuner last time, but you should do this before you do your PID tuning. But yeah, right there, set to false. That's fine. All right, and then we need our PID constants. So that's easy enough. Master talon dot config KP. and you're going to want to have a slot index. So that's going to be maybe, let's do 0 for now, and then robot map dot test motors dot kp position. Oh, one timeout for that as well. Robot map dot timeout. There it is. Oops. Good. So that's going to configure our KP in PID slot 0. Remember, different from index. Index is the PID loop. Slot is just like a set of constants. And we're going to set that equal to KB position, which we just entered in as 1.5. Similarly, we can just copy this line here for KI and KD. I and D. Change this to I and D. And there we go. And this slot 0 here, it's not great to hard code it in like this. Really, I should have like a constant in here that says like position slot equals 0. Yeah, I want to do that. Why not? Let's do private int position slots equals 0. There you go. That's a bit more robust because it means that if I change like my PID slot setup, then I'm still fine. This is inner loop, so I'm just going to leave it as hard-coded inner loop, unless I really am going to use the outer loop, and most of the time you're not going to use the outer loop, so it's fine. Alright, so there's that, and last thing we need to do is config integral zone. So master talon.config integral zone. It's going to be slot position slot. iZone, that's going to be in robot map dot test motors dot integral zone, and a timeout of robot map dot timeout. There it is. All right, and that's it for the setup here. So here we set up our PID stuff, we set up our integral zone, sensor phase, and selected feedback sensor. So the last thing that remains is to actually make the robot move. So to do that, I'm just going to come over to commands, right click, create a new class / command, and we want to make a regular command, and let's call this go to position. All right, that should be fine. And I should capitalize that actually. Because class names, capitalization, all that good stuff. Yeah, there you go. Okay, and of course we're given all of our default command stuff. And this command is fairly straightforward. Basically, we're just going to do a couple initialize things, and then we're going to execute the go to position. So the first thing I'm going to want to do is I'm going to want to add a bunch of includes here. So I'm just going to go to drive with % here, and I just copy over my imports just so I don't do anything weird by mistake. Test motors, I'm also going to include all this CTRE stuff because we're going to be accessing some Talon methods in here. And that should be good enough. So now I'm go to position, I'm going to make sure that because I'm using the arm here, I don't want two things accessing the arm at the same time, so I'm going to use requires. So requires I want robot.testMotors. There you go. It might throw me an error because I don't like it, but it definitely exists. So that's just going to define different conflicts. Now I want to add a robot.testMotors.select profile slot 00. And what's select? I'm just taking a second here to update. Oopsies. Master Talon. Select profile slot. So what select profile slot is going to do is basically going to link a PID slot to a PID loop. So remember, like I mentioned before, there's two PID loops. There's an inner loop and an outer loop. You can use different sets of PID constants for them. For example, if you want to do like a position loop in the first one and then an angular loop in the second one, you'd have different PID constants for that. So you're linking a slot to an index here. So I can do 0, 0. Actually, doing better, I can make this a public int. And then here, I can change this to robot.testMotors.position slot. So there's that. And finally, in execute, we're going to want to do the set. So first I'm going to go back to test motors here, and I'm going to add another thing. So right now we have the drive that's used by drive with %. Remember, we do robot.testmotors.drive. Here, I want to add another one that's called like go to position. So public void set position and int target. So I'm going to call that master talon.set control mode. Let's see, control mode dot position and a demand of target. Now go to position. I'm just going to go ahead and call robot.testmotors dot set position, and we're going to pass in. Oh, we need to make sure we add some kind of target here. So int target. I call this int target. It's like an internal target. And so now I'll say target equals target. So I pass in a target position. It goes into this guy and do set position target. And there you go. And now when I press a button or something, whenever I bind this to, it'll go to a position defined by underscore target. And this is going to call the method in test motors that actually moves the motors. That's the way it should be. Let me fix this formatting a bit. There you go. Last thing I need to do is I need to define an is finished. So this is a little tricky because for going to a position, for example, for an arm, there might be a time when I want to go to the position and then move it manually, maybe tweak it a little bit, like in case something's going wrong with the robot, right? And in those cases, I want to make sure I can override this command. Otherwise, nothing's going to happen. So this right now will make it so it never finishes. So it'll just, I won't be able to go back to manual control unless I manually somehow kill this command, which is very difficult. So instead, I'm going to go ahead and use OY methods to figure out when the driver's moving the joystick, and if they do, stop this position control method. So to that end, this is actually fairly straightforward. Basically, I'm going to say if OI.get. Did I didn't include OI for this? I already included this stuff, right? Yeah. So as you want, if the Y is greater than the dead zone, so greater than OI.dead zone, and right here, the X is greater than the dead zone. Actually, it should be called dead zone, yeah. And the X is greater than the dead zone. So, or greater than dead zone, then return true. And otherwise just return false. So basically, if the person pushes the left joystick in any direction, it'll end the command. Now, of course, it's still the interrupted, and when that happens, so we call end. There you go. So it's still the interrupted, so if you call another position control command, it'll interrupt this one and like cancel it basically. That's fine. Okay, there you go. So now I can call go to position, and it'll go to position as long as the driver isn't hitting a joystick. And last thing we need to do is link this to OI. So I'm going to come over to OI, and we're going to add in my OI constructor here. Let's make this button y.when pressed. So when I press the Y button, let's do new go to position 496. There you go. And now I will go to a position of 1 forward rotation. Actually, it's a little high. Let's do 124. I'll go to a position of 90 degrees when I press the Y button. And I'm going to make one more command, just because it makes sense to me to make this command. I'm going to make a zero encoders command. So create a new class command. Let's do command 0 test encoders. And all this is going to do is in initialize. We'll talk about this. I'm going to copy all this over. This stuff over. OI, go to position. Here we go. I'm just going to in initialize just say robot.testmotors.mastertalon.set sensor sensor position 0, index 0, in robot map.timeout. There you go. So all it's going to do is it's going to initialize, it's going to set select to 0, and then immediately return true and exit. And also I'm going to do a quick little print line. Zeroing encoders. Not serial. System.out.println. Sorry, it's been a really long time since I've actually used Java. I've been doing too much Arduino recently. So yeah, there it is. So now I can go to OI and I can bind that to a button as well. Let's use A, why don't we? Button Y dot when pressed new 0 test encoders. And there you go. Now it will zero the encoders. Now really what I should do is in test motors I should do something called like public void 0 encoder int pause. And what this is going to do is going to be like master Talon dot set selected sensor position pause 0 robot map dot timeout. And then I would call 0 encoder from here. That's technically better because this way I can keep my important methods inside test motors and just call them from the command. But honestly, for something as simple as this, it doesn't really matter. Both will work just fine. So that's pretty much it. Thanks for watching. Just to recap real quick, basically I made a go to position command, and the go to position command is going to select a profile slot and it's going to call the new set position method in test motors. In test motors, we added sensor feedback stuff, we added sensor phase stuff, PID and iZone stuff, and we added the set position command. And in robot map, we added the sensor direction variable and the KP, KI, KD closed loop ramp variables. Oh, we should probably actually use closed loop ramp, huh? So in test motors, real quick, master Talon dot close loop ramp. Here you go. Robot map dot test motors dot close ramp. There it is. And timeout of robot timeout. There you go. Now we're done. So there you go. It's that easy. I mean, yeah, there's like a few things you got to set up. You got to do all this stuff, but for the most part, like we could have skipped integral zone. We could have skipped closed loop ramp. We could have made the command structure a little bit like less convoluted, if you will. Like, you know, had instead of putting the methods in here, put them straight in the commands. But this is more proper, so I'm going to stick with it for now. The next video is going to cover implementing position control with motion magic, which is like PID, but it uses a smoother path to get to the target instead of just snapping to there. So I'll cover more about motion magic in the next video. So thanks for watching, and I'll see you again soon.